back. Okay, here is our next video. It's on the addition rule and its complements. Okay, so if you have a calculator handy, make sure you do. Also, I have the PowerPoint slides. You can just write on them, print them out, and then write on them afterwards. It's up to you as how you want to take notes for this section. Okay, so we're going to dive into it because there is a little bit here that is going to take some time. Okay, so let's jump into it. Disjoint events. Okay, if two events cannot happen at the same time, they are said to be disjoint. Okay, well, pretty much we also call them mutually exclusive. Okay, there's so many words when it comes to geometry, and not just geometry, other math classes where it's like, okay, what word am I going to use? And a lot of them mean the same thing. Mutually exclusive is what we're going to start talking about a lot of. Okay. And then how does this look as a Venn diagram? Well, let's think about it. If you remember back when you did Venn diagrams in your English classes, okay, if two events have nothing in common, it would be two circles that don't overlap. Okay, so that's what it would look like as a Venn diagram. And we're going to actually do a lesson with Venn diagrams at the very end of this unit. Okay, so that's going to be coming. So here's three situations, and I'm sorry if you can't see it. Like I said, you do have the notes with you. All we're going to determine, is it mutually exclusive or not? So here we go. Han rolls a fair six-sided die. Determine whether rolling a 4 or an odd number is disjoint. Mutually exclusive. Okay? So does rolling a 4 affect you rolling an odd number on a die? Do they affect each other at all? Okay, answer is no. So for A, that is going to be mutually exclusive. Okay? Part B. Han draws one card from a stand-up deck. Determine whether drawing a king or a club is disjoint. Okay? So, is there anything in common with a king or a club? Now, if you're not a card fan, this might be kind of hard for you to answer. But the result of this would be not mutually exclusive. I'm going to abbreviate. Because there is a king of clubs. You could draw both of them. Okay? They do affect each other there. And the last one, part C. Okay? Selecting a number at random from 1 to 100 and getting a number that's divisible by 5 or divisible by 10. Okay? Is that mutually exclusive or not? Well, let's think about this. Is there numbers out there that could be divided by 5 and 10? Yes. For instance, 30, right? 30 can be divided by 10 and 5. So they both could happen, right? They both affect each other. So in this case, it would be not mutually exclusive. Okay? Just a couple examples just to get you familiar with mutually exclusive and not mutually exclusive. Okay? So the first one, the outcomes don't affect each other. The other two, they do. So what do we do with this? How do we calculate a probability for something like this? Turns out we're just adding the events together. Okay? And this is the notation we're using for it. So if E and F are mutually exclusive, then the odds of E or F happening is the probability of E plus the probability of F. So just remember, P represents probability, and parentheses is what we're looking at. Okay? Let's do a problem. Trevor reaches into a can that contains 30 quarters, 25 dimes, 40 nickels, and 15 pennies. What's the probability that the first coin he picks is a quarter or a penny? Okay? So the probability that he gets a quarter or a penny. Excuse me. So, first off, we know from basic probability, the total goes here at the bottom. So how many total coins do we have in this can? We just need to add the numbers up. Okay? So we should get 110. There are 110 coins in this can. Now, how many of them are quarters? Well, if you take a look, 30 of them are. But do we just want quarters? No, we want pennies as well. So we're going to add, was it 15 pennies? Okay. So usually we only have one number up here, right? When we calculate a straightforward probability. But I'm no longer interested in one event. I'm interested in two events. So I'm going to add those together because there's more stuff I'm interested in. Okay? So that'll be 45 out of 110. Right? And when you divide, you get 0.049, or roughly 41%. Okay? So you have a 41% chance that when you reach your hand into the can, that when you pull out a coin, it's a quarter or a penny. Okay? So hopefully you see the difference between probability of one thing and the probability of multiple things. Okay? Now, let's say I wanted to put in there dimes as well. I have another or there and put dimes. Then you're just going to add 25 to this list. Okay? So however many you're adding to it, you're just going to add in with the probability. Okay? Now the last part says, how does this look as a Venn diagram? Well, okay, as a Venn diagram, let's say this is the can, and I have 30 quarters, 40 nickels, 25 dimes, and 15 pennies. Okay, as a Venn diagram, I want to know what are the odds of a quarter or a penny, so I'm adding the 30 and the 15 together. I want elements that are in this bubble and this bubble. Okay? Out of a total of everything here, which is 110. So visually, that's what it looks like. Okay, marbles. Harry collects colored marbles so he can play with his friends. The local store has a grab bag. 15 red, 20 blue, 3 yellow, 5 mixed color are in this bag. He reaches into the bag and selects a marble. What's the probability that it's red or mixed? Okay? Or one of those mixed colored ones. So, probability that we get a red or mixed. Same premise. The total goes on the bottom. What goes on the top is what we're interested in, which is 2 things this time. And I encourage you to pause the video so you can do this yourself. Okay? So total in the bag, we have 43 marbles. Okay, when we add those up. Now, how many of them are red? 15. How many of them are the mixed colored ones? 5. Add them together, we get 20 out of 43, which as a percent, well, first is a decimal before we multiply. Okay, we get 0.4651, or roughly 46.5%. Those are the odds, almost close to 50%, that you're going to pick a red marble or a mixed color marble out of the bag. Okay? So we're just adding things together. And like I said, if I had this, red, or the mixed color marble, or yellow, if I add another element to this, well, it's the 15 plus the 5 plus the 3. Okay? Remember, the top number is just what we're interested in. And whatever we're interested in, we're increasing that number. Okay? There's more things in the sample space we want to select. And that's what we're looking at here. Okay? Questions? Good. You guys are very quiet at home. You got to speak up. All right. Next problem. Okay? Card problems. Now, once again, if you're not a card person, that's okay. I still want to go through these a little bit. I won't be throwing a lot of card probability at you. Okay? I think I might have 1 or 2. I don't remember. So we have 52 cards in a deck. There's 13 cards in each suit. There's 4 kings, 4 queens, 4 jacks, 4 aces. And then we go from 2 to 10 for the number of parts. Okay? Once again, if you know these, if you know the basics of cards, pause the video and try these out. I'm going to go through these rather quickly, though. So what are the odds of drawing a king? So there's 52 cards in a deck. There's 4 kings in a deck. So this one would just be 4 out of 52. Okay? As a percent, I'll give you the decimal first so you can see it. It's roughly 7.6%. Those are the odds of you drawing a king randomly out of a deck. Not too high, but we should expect that. The number up here is very tiny. So it's not going to be a big probability for us. Okay? Next, king or queen. So we're still taking out of 52 cards in the deck. Now, how many kings and queens are in the deck? Well, there's 4 kings, and there's also 4 queens. So we're going to add those up. And we're adding them because, once again, there's more things in the deck that I want to pick, that I want. Okay, so that means my sample space, a subspace, is getting bigger. So it's 8 out of 52. Okay, I'll give you the decimal. Okay, it's 0.153 or 15.3% chance. Okay, so as you can see, the more cards I add to it, the bigger the probability is I'm going to select something like that. Now let's look at the last one. King or queen or jack. Remember, I just said this too, ironically. I have 3 things that I want out of this deck. So that means I have a better chance of getting something that I want. So there's 4 kings, there's 4 queens, and 4 jacks. So we have a 12 out of 52 chance of getting what I want. And for that guy, looking at the wrong part, okay, we get 0.2307 or 23.1%. If I round a little bit, so a 23% chance that the first card I select is a king, queen, or jack. Okay? So if I have 5 things listed here, you list all 5 at the top and put the total. All right? Now, what happens when there is something in common? Okay, what happens when they're not mutually exclusive? What if there's some overlap here? What do we do? Well, we are still going to add the probabilities, but now we're going to subtract them. That's what the and indicates, okay? The probability of them both happening. And the reason why we're doing this is because we're double counting. Okay, we're including an element twice, and we don't want to do that. Now, right now, it doesn't seem very clear, but when we do a couple examples, it's going to show. Okay? So, let's take a look at this table here. This is the results of a company testing a medicine for migraine headaches. So, if you have migraine headaches, this is something that might pertain to you. Okay, so look at this. This is a frequency table, which just means it's telling you how many of something is happening. So, headaches went away. Given medicine. 132 were given the medicine. 56 were given the placebo. 188 of them had their headaches go away. Headaches that lingered. 18 were given the medication. 44 were given the placebo. And 62 of them didn't have their headaches go away. So that's what it means when you read it by column. Now look by row. How many total people were given medicine? 150. Okay. How many total people were given the placebo? 100. And how many total people were in the survey or the testing? 250. The corner piece tells you how many total is in your survey or table. The other ones tell you the totals for the rows. And then for the columns, the bottom part is the total for that. So how many people did their headache go away? 188. How many lingered? 162. And the total was 250. Okay? Just a little quick reading into this. And I highly encourage you, if you can print the PowerPoint slides out or if you can write on them, this would be perfect. Okay? And you want to save it because I'm going to do a notebook check, but that's going to be a lot easier for you. So for A, what's the probability that a person was given a placebo? Okay? So that's what we're going to do first. So let's take a look here, okay? The bottom of a fraction is always the total of everything. So what are the total number of people that were in this test? We already said it, 250, okay? It's here at the corner. That's how many total people were here. How many had the placebo? Well, look at the placebo row and go all the way across, and we see there is 100. Okay, so 100 people were given the placebo. Okay? So what are the odds of this happening? Well, go ahead and divide these two, and we get 40%. Okay, it's a 40% chance that they were given a placebo. Okay? Part B. What's the probability that our headache went away within 45 minutes? So headache, we'll say head away. Our headache went away. All right? So how many total people were there again? There were 250, right? Out of this group, how many of them had their headache go away? So go where the category is. Headache went away. Go all the way at the bottom. There were 188 of them. Okay? So that's what we're going to do. We're going to put 188 on top. Okay? Divide these two, and we get 75.2% chance that their headache went away. Okay? That's a good thing, right? If you're doing drug trials and your drug is producing a 75.2% chance of it working, you're onto something. It's not great yet, but you're onto something. Okay? Now, A and B, I've done simple probability. I haven't done anything complex yet. Okay? Part C. What's the probability that she was given the placebo and her headache went away within 45 minutes? Okay. So we're getting a little bit more specific. So the headache went away, or, given placebo. Okay. Now, we're still going to put the 250 on the bottom, right? There's 250 people. Now, there's an intersection going on here. Headache went away given the placebo. How many people were given the placebo and their headache went away? Do you see that number on the table? It's right here. Given the placebo, headache went away. They both intersect at 56. There were 56 people that were given the placebo and their headache went away. So this one's going to be out of 56. Okay? So it's still straightforward probability. I didn't add, I didn't subtract yet. We're getting there. But this is a little more specific. And this table, like reading this table, is very important. So let's go ahead. We'll divide and multiply. I'm running out of space, so I'm just going to give you the percent. It'll be 22.4%. Now, I highly encourage you to make sure that you can type in the calculator and you get the same answer. Okay? All right. Now, the last one. Okay? What is the probability that she was given a placebo or her headache went away within 45 minutes? There's an or there. So probability of a placebo or the headache went away. I know that was pretty, that's a big set of parentheses there. Okay? All right, so let's add these up. I know it's hard to look at the table when you're thinking of all this stuff, but let's be very systematic about it. Placebo. How many placebo people were there? So you go where placebo is, go all the way across 100. There was 100 of them. Plus, how many people's headaches went away? Headache went away, total 188. Do you see the problem yet? We counted a group of people twice. Do you see it? I counted this column this row, what number is included in that total twice? 56. These 56 people were counted in this group and in this group. So I double counted. Does that mean my probability is going to be off? It is. So to balance it, I'm going to take 56 out of the equation there, okay? Because think of it. There's 56 people in here, 56 people in here. I counted them twice. So if I subtract them out once, I'm only counting once, okay? Go back through that explanation, look at the table, think about that, okay? It's very important. So this is a not mutually exclusive event, right? These both can happen at the same time. And then this is out of 250 people still, okay? So can there be people that have the placebo and their headache went away? Absolutely. Okay, divide, multiply by 100, we get 92.8%. Okay, sorry, usually I'd write this down, but we're getting out of space here. So it's a highly probability that the person was given a placebo or their headache went away. Okay? Does that make sense? Think about that. Think about why we're subtracting here. It's because these 56 people were in this group and this group. So we don't want to count them twice. Okay? All right. Let's do one more, and then we'll talk about complements, and that's the end of the video. Okay? So below we have all these paintings that this person created, right? And look at all the different things here. We have still life paintings, portrait, and landscape. And within each one of those, they are watercolor, oil, acrylic, and pastel. Now, if you're an art person, then you know exactly what these are. If you're not an art person, well, you're in the same boat as me. Okay? Not that I don't appreciate art. I do. It's just sometimes I have a hard time understanding it. Okay, so it wants to know what's the probability that Namiko selects a watercolor or landscape. Okay? So here we go. Probability of a watercolor or landscape. Okay? Now notice, this table doesn't give you any totals, right? See how there's no totals? So you're going to have to add these up yourself. So just for sake of time, there are 30 paintings. If you add all these numbers up, you get 30. Okay? How many paintings are watercolored? So go where watercolored is. 4 plus 5 plus 3. So that's what? 12. So there's 12 total. Okay. Now how many are landscape photos? Well, there's landscape. Add these numbers up. 3, 2, 1, and 5. So that's what? 11, right? Okay. Now, do you see an issue? I color-coded this, so you might see the different colors sticking out. I counted these paintings and these paintings. There's a group of paintings I counted twice. These three, right? They're both landscape and watercolored. And because of that, they got included in this group and this group. I don't want them to be counted twice. So I'm going to subtract 3 of them. Okay? All right, now we simplify. So we get 20. Oops, that's a goofy looking 20, sorry. So 20 out of 30, or 66.6% chance that Namiko, when she selects a painting randomly from her collection, that it's watercolor or landscape. Okay? And if you have questions on this, please don't hesitate. I'd be glad to explain it to you a little bit differently. But hopefully you can see from the table and chart that when we count things twice, we got to subtract them out. Okay? And this is not mutually exclusive. These both can happen at the same time. There's 3 paintings that have both those characteristics. Okay? I'm going to go ahead and skip this card one. So the last part, and And if you watched my last video, you've seen this already, okay? I forgot I included it in this PowerPoint. Complement. When you hear the word complement, that means what are the odds of it not happening? So to do that, you do 1 minus the odds of it happening. So I think I used the example of a test. If you have an 80% chance of you passing the test, the complement's failing it. So you actually have a 20% chance of failing. See how you're just subtracting it from 1 or 100? Okay? So that's what a complement of an event is. So we get these last two problems that we're going to try out. Miguel bought 15 chances to pick the one red marble from the container to win a gift certificate from the bookstore. There's 200 marbles in the container. What's the probability that Miguel will not win the gift certificate? Now, we usually say, what are the odds of him winning? 15 out of 200. But now we're saying not. Okay? So what does that mean? So that's the complement, something not happening. So not winning. Sorry, Miguel, you're not winning this time. All right, so, it's going to be 1 minus the odds of him actually winning, right? So the odds of him actually winning is 15 out of 200. And what we're going to do is we're going to take it from 100%. Now, why is this not 100%? Why is it just 1? Well, remember, we don't convert things to percents until afterwards, right? Most of our probability when we divide them is decimals. So 1 times 100 is 100%. So we are subtracting from 100, okay? It just isn't written like that because we're dealing with the number form of it without percents yet, okay? So we'll go ahead, do 1 minus the 15 out of 200, plug those in your calculator, okay? And you get, I can't write today. All my zeros are becoming ones for some reason. Okay, you get this decimal, which comes out as a percent, as 92.5. Okay? So it's always 1 minus this guy. So in your calculator, you can type that. Just be careful on how you type that in. And the last one. And I encourage you to pause the video and try it. At a carnival, Sergio bought 18 raffle tickets in order to win a gift certificate to the local electronics store. There's a total of 150 raffle tickets sold. What's the probability that Sergio will not win the gift certificate? It's pretty much the same as the previous one. So the probability to not win, which don't you always want to know those odds? The odds of you not winning. Okay? So it's going to be 1 minus the odds of him winning, which is what, 18 out of 150? Now notice something. See how they give us fractions? So they kept it as a fraction this time. They didn't give us as a decimal. Okay? Now there's a lot of ways you can do this. You can convert these to decimals and see if it compares to the decimal answer you got, or keep this as a fraction, which we can do that. That's not too bad. So I'm just going to work with the fractions a little bit here. Okay? So if this is over 1, common denominator is 150. So this would be 150 over 150 minus 18 over 150. Okay? So we're going to get 132 out of 150. Okay? Now here's the deal. This is my answer, but it doesn't come up there. And this sometimes can happen, like state tests or ACT. They reduce the fraction. So you got to come up with a way, like what number goes into both of these. Okay? And I believe that number is going to be 6. 6 can go into both of these guys. So when you reduce it, you get 22 out of 25, which our option would be B. Okay? So the option is B for that guy. Now once again, if you were given this problem and they didn't have the multiple choice there, you could do 1 minus the fraction, get your decimal answer, multiply by 100, and be done. That's perfectly fine. Okay? I don't want you to think you have to do it this way that they're showing you here. Okay? So that's it. That's mutually exclusive events. Sometimes they're called disjoint. Please watch the video a couple times if you're not sure of things. Ask me for help. Don't be afraid to email me. But other than that, that's it, guys. Okay? So good job. and I'll see you guys in the next video.